In November of 2025, a crew of astronauts was getting ready to come home. They'd finished their mission aboard their space station, they were preparing to undock and begin the journey back to Earth. And then they noticed something that stopped everything cold. Tiny cracks had appeared in the window of their spacecraft, not from a manufacturing defect, not from wear and tear, from an impact, a strike from a piece of debris zipping through orbit at thousands of miles per hour. And just like that, their ride home was deemed unsafe. These astronauts were, in effect, stranded in space, and it took an emergency rescue launch to bring them back. The first mission of its kind ever required in that nation's human spaceflight program. Think about what that means. An entire crew's journey home derailed, and a rocket hastily prepared and launched, all because of a collision with a piece of space junk. That should make you sit up. The object that cracked that window was almost certainly just one tiny fragment out of an estimated 140 million pieces of junk currently circling our planet. That's not science fiction. That's the reality of Earth's orbit right now. A reality that is far more crowded, far more dangerous, and getting worse far faster than most people have any idea. So today, we're breaking down exactly what's happening up there, why the experts are genuinely worried, and what it means for all of us down here on the ground. No exaggeration, no doom for the sake of doom, just the real numbers, the real incidents, and the honest science, because this is one of those stories where the truth is alarming enough on its own. But before we dive in, do me one quick favor, because it genuinely helps this channel. Drop a comment right now and tell me where you're watching from and whether you've ever even thought about this problem before. The idea that the space around our planet is filling up with junk. Most people never think about it, and I'm curious how many of you have. And if you want to actually understand the forces shaping our future in space instead of just seeing scary headlines, hit that subscribe button. It's free, it takes 1 second, and it means you'll always get the real explanation. A thumbs up helps push this out to more people who deserve to understand it. All right, let's get into it. Let's start with the sheer scale of the problem, because the numbers are genuinely staggering and they're the foundation of everything else. As of early 2026, researchers estimate there are more than 140 million pieces of debris orbiting the Earth. Let that number sink in, 140 million. Now, most of those are tiny, flecks of paint, bolts, shards of metal, fragments smaller than a centimeter. But there are also the big pieces, defunct, dead satellites that no longer work, and spent rocket bodies, the discarded upper stages of rockets, some of them the size of a bus. In terms of objects big enough to actually track from the ground, space agencies now catalog more than 40,000 of them, a record-breaking figure that keeps climbing. And sharing that same space are the things we actually want up there, on the order of 14,000 functioning satellites, the ones that power our modern world. And here is the crucial thing to understand about why all this junk is so dangerous, and it comes down to one word: speed. Objects in low Earth orbit are traveling at speeds exceeding 17,000 miles per hour. At that velocity, even a fleck of paint carries a shocking amount of energy, enough to pit and damage a spacecraft. A fragment the size of a marble hits with the force of a bullet, and a piece the size of a baseball could completely destroy an operational satellite or punch a catastrophic hole in something like the International Space Station. This is the key mental shift you need to make. Up in orbit, size doesn't determine danger the way it does on Earth. It's the speed that makes even the smallest debris lethal. That cracked window I mentioned at the start, it was almost certainly caused by something quite small. Small, but moving fast enough to threaten the lives of the crew. To really grasp why, it helps to think about the physics. The energy carried by a moving object doesn't just add up with speed, it climbs with the square of the speed. Double the velocity, and you quadruple the energy of the impact. And orbital objects aren't moving at highway speeds. They're moving at something like 10 times the speed of a rifle bullet. When two objects in orbit meet head-on, their combined closing speed can be tens of thousands of miles per hour. At those velocities, a collision isn't like two cars bumping, it's an explosion. The impacting fragment and the target both essentially vaporize and shatter, releasing energy comparable to a small bomb and spraying out a fresh cloud of high-speed fragments in every direction. That's why a fleck of paint can crater a window and a lost bolt can kill a satellite. In orbit, everything is a bullet, and the tiniest debris hits like something far larger. And nearly all of this is concentrated in one region, low Earth orbit, the band of space within roughly 2,000 kilometers of the surface. That's the most valuable real estate in space. It's where the International Space Station orbits, where most Earth imaging and communication satellites live, and increasingly where enormous fleets of satellites are being launched. It's the busiest, most crowded neighborhood above our heads, and it's exactly where the junk is piling up the most. And here's a detail that makes the whole problem even more unnerving. The 40,000 objects we track are only the ones big enough to see. Remember that estimate of 140 million total pieces? Do the math And it means the overwhelming majority of the debris, the tens of millions of fragments between a millimeter and 10 centimeters across, is completely untrackable. We cannot see it, we cannot catalog it, and we cannot warn satellites to dodge it. It's essentially an invisible cloud of shrapnel. And any one of those unseen fragments moving at orbital velocity is capable of disabling or destroying a satellite on impact. So when operators perform their careful collision avoidance maneuvers, they're only dodging the threats they can actually see. The far larger population of debris, the swarm we're blind to, is a constant silent game of Russian roulette playing out above our heads every second of every day. That cracked spacecraft window was almost certainly the work of one of these invisible bullets, something far too small to have ever appeared on any tracking screen. So the situation is already crowded and dangerous. But here's what really matters, and it's the part the title is pointing to. It's getting worse and fast. According to the European Space Agency's latest annual assessment of the space environment, the risk of debris collisions in low Earth orbit has risen 20% just since 2024. 20% in about 2 years. That's not a slow creep. That's a rapid acceleration of the danger, and the experts point to a few specific drivers behind it. The first driver is the mega constellations. In recent years, companies have begun launching satellites not by the dozens, but by the tens of thousands in massive networks designed to blanket the planet with internet coverage. This has caused the number of active satellites to explode. And while these constellations provide genuinely valuable services, they also dramatically increase the sheer density of objects in orbit. More satellites means more potential collisions, more objects to track, more chances for something to go wrong. The second driver is deliberate destruction, specifically anti-satellite weapons tests. Over the years, several nations have tested weapons by blowing up their own satellites in orbit, and each of these tests is an environmental catastrophe for space. When you destroy a satellite, you don't make it disappear. You shatter it into thousands upon thousands of new fragments, each one a new high-speed hazard, and many of them spread out into orbits, where they'll linger for years or decades. Back in 2021, one such test forced astronauts aboard the International Space Station to take shelter in the capsule they used to return to Earth, in case they needed to evacuate from the debris cloud. Every one of these tests adds to the accumulating, long-lasting toll. And the third driver is the most insidious. The rate at which debris is being created is now outpacing nature's ability to clean it up. Here's what I mean. There is a natural cleanup process in low Earth orbit. The thin wisps of Earth's atmosphere that extend up to those altitudes create a tiny amount of drag, which gradually slows debris down and pulls it lower until it eventually re-enters and burns up. It's the planet's built-in janitor. But that process is slow, and it only works efficiently at the lower altitudes. And right now, we are generating new debris through collisions, explosions, and launches, faster than that natural drag can remove it. So the total keeps climbing. The bathtub is filling faster than it can drain. The result of all this is captured in one striking statistic. In certain busy bands of orbit, the rate at which operators receive collision warnings, alerts that two objects might crash into each other, is now roughly 5 to 10 times higher than it was just a decade ago. Satellite operators are constantly having to perform avoidance maneuvers, firing their thrusters to dodge incoming debris, burning precious fuel each time and shortening their satellites' lifespans. Economists at the World Economic Forum have described this as a kind of hidden tax on all space operations. It doesn't usually show up as one dramatic, headline-grabbing disaster, but as a constant, grinding erosion. Higher insurance premiums, more fuel wasted on dodging, shorter satellite lifetimes, and more friction for anyone trying to operate in orbit. It's death by 1,000 cuts, and the cuts are coming faster every year. Now we need to talk about the nightmare scenario, the thing that keeps space scientists up at night, because it has a name, the Kessler syndrome. Back in 1978, a NASA scientist named Donald Kessler, along with a colleague, published a paper describing a terrifying possibility. Imagine that two large objects in orbit collide. That collision shatters both of them into thousands of new fragments. Those fragments then spread out and increase the odds of more collisions. Each new collision creates yet more fragments, which cause yet more collisions, and so on. It's a chain reaction, a cascade, that once it gets going could become self-sustaining, feeding on itself and generating more and more debris, even if we stopped launching anything new tomorrow. And here's the truly frightening part of the Kessler scenario. If it ran to its conclusion, it could render entire regions of orbit so thick with debris that they become effectively unusable. Too dangerous to fly through, too dangerous to place satellites in. We could, in the worst case, lock ourselves out of parts of space for generations. For decades, this was treated as a theoretical worry, a scary thought experiment. But as launches have surged and the debris has piled up, it has started to look less theoretical and more like a real approaching threat. Some experts note that the early warning signs of a cascade, rising collision rates, growing debris in specific bands, are already visible in the most congested orbits. We may be watching the opening moves of exactly the scenario Kessler warned about nearly 50 years ago. Let me bring this back down to concrete reality, because this isn't just abstract math. It's already causing real incidents. I told you about the astronauts stranded by a cracked window in 2025. But consider this. The problem isn't even confined to space anymore. In 2024, a piece of debris from the International Space Station actually survived its fall through the atmosphere and crashed through the roof of a home in Florida. Thankfully, no one was seriously hurt. But think about what that means. Space junk is now, on rare occasions, literally falling out of the sky and hitting the ground where people live. And as more and more objects go up, and more of them eventually come back down, the odds of these re-entry incidents only grow. So the situation in Earth's orbit isn't a distant problem happening in a place that doesn't affect us. It's already reaching down and touching the surface of the planet. Now, I want to be balanced and completely honest with you here, because responsible reporting means telling you the full picture, not just the scary half. And the honest truth is that there is real progress being made, and the situation is more nuanced than pure doom. That same European Space Agency report that flagged the rising collision risk also documented genuine improvements in how operators are behaving. For example, around 90% of rocket bodies in low Earth orbit now comply with the international standard that says you should remove your object from orbit within 25 years of the end of its mission. And around 80% comply with the ESA's even stricter 5-year standard. That's meaningful. It means the industry is increasingly taking responsibility, designing satellites and rockets to safely dispose of themselves. So this is not a hopeless, unstoppable death spiral where nothing is being done. It's a serious and worsening problem that is running up against a growing, if still insufficient, effort to address it. The truth lives in that tension. Real danger, real progress, and an open question about whether the progress can outpace the danger. That's the accurate picture, and it's the one you deserve. So why should any of this matter to you, someone living your life down here on Earth, probably never planning to go to space? Because you depend on that orbital infrastructure every single day, whether you realize it or not. The satellites in low Earth orbit and beyond are the invisible backbone of modern civilization. GPS navigation that guides your car and your phone, weather forecasting that warns you about storms, global communications, television, and increasingly, internet access, especially in remote areas, the timing signals that synchronize financial transactions and power grids, Earth observation that monitors crops, climate, and natural disasters. All of it runs through space. So if the debris problem were ever allowed to spiral out of control, if we were to lose safe access to key orbits, we wouldn't just lose some satellites. We would lose pieces of the infrastructure that our entire modern world quietly runs on. That's what's actually at stake. It's not about protecting a few expensive machines. It's about protecting a system that billions of people depend on. There's also a quieter casualty in all of this that's worth mentioning: the night sky itself and the science of astronomy. As tens of thousands of new satellites fill low Earth orbit, they don't just create collision risk, they also reflect sunlight, appearing as moving streaks of light across the sky. For astronomers trying to study the universe, this is a growing headache. Bright satellite trails, photobomb telescope images, interfering with observations of distant galaxies, asteroids, and other objects. Some worry that the sheer number of satellites and debris could permanently change humanity's view of the cosmos, dimming our connection to the dark, star-filled sky that every generation before us took for granted. It's a subtler loss than a satellite collision, but it's part of the same story. The crowding of orbit has consequences that reach into science, culture, and even the simple experience of looking up at night. So what's being done about it, beyond just better disposal? Because there are people working hard on solutions, and some of them are genuinely fascinating. The most direct approach is called active debris removal, actually going up and cleaning the junk out of orbit. Companies are developing servicer spacecraft that can rendezvous with a dead satellite, grab hold of it, and drag it down to burn up safely in the atmosphere. A company based in Japan and the UK has already demonstrated the technology for capturing and deorbiting a target, and a European effort has a contract to attempt a cleanup mission in the near future. There are other ideas too, deploying drag sails on satellites, which are like parachutes that catch those thin wisps of atmosphere and pull the satellite down faster at the end of its life. There's even experimental work on using ground-based lasers to gently nudge small fragments into lower orbits where they'll decay. Though that one is politically delicate, because a ground laser that can push a satellite could, in the wrong framing, look a lot like a weapon. But here's the catch, and it's a big one. The economics don't work yet. A single debris removal mission can cost tens of millions of dollars, and right now, there's no clear system for who pays for it. The debris is a shared problem. Everyone contributes to it. Everyone is threatened by it. But that also means no single company or country has a strong financial incentive to foot the enormous bill to clean it up. It's a classic tragedy of the commons, a resource that everyone uses and no one is fully responsible for protecting. Until the economics change, or until governments step in to fund and require cleanup, the technology to solve this may exist while the will and the money to deploy it at scale do not. And that points to the deepest part of the problem, which is ultimately about governance and cooperation. The foundational rules for behavior in space date back to a treaty from 1967, a time when only a couple of nations were even capable of reaching orbit. The world of space today, with thousands of satellites from dozens of countries and private companies, has completely outgrown that framework. Experts increasingly argue that what's needed is stronger international cooperation, mandatory, enforceable disposal plans for everything launched, real restrictions on those destructive anti-satellite weapons tests, and shared systems for tracking objects and coordinating to avoid collisions. The technology challenges are hard, but the political and cooperative challenges may be even harder. Space is a global commons, and protecting it requires the kind of coordinated international action that humanity has always found difficult. So here's the honest bottom line. The situation in Earth's orbit really is worse than most people think. There are an estimated 140 million pieces of debris circling the planet, tens of thousands of them large enough to be catastrophic, all moving fast enough that even tiny fragments are deadly. The collision risk is climbing rapidly, up 20% in just 2 years, driven by exploding satellite numbers, deliberate destruction, and a cleanup rate that can't keep up. Real incidents are already happening, from stranded astronauts to debris crashing through roofs. And the nightmare of a runaway chain reaction, the Kessler syndrome, has moved from theory toward a genuine, if not yet realized, possibility. But, and this matters, it is not hopeless. There is real progress on responsible behavior, real technology being developed to clean up the mess, and a growing global awareness that something has to be done. The question that defines the coming decades is whether our efforts to protect orbit can outpace our ability to pollute it. The stakes couldn't be higher because the invisible infrastructure up there holds up the world down here. I'm going to keep tracking this story every step of the way. Every new incident, every cleanup mission, every shift in the numbers and the policies. If you want to actually understand what's happening above our heads instead of just seeing the occasional scary headline, subscribe right now so you don't miss an update, because this is one of the most important and least understood challenges of our time. Hit that like button to help this reach more people who deserve to understand it. And drop a comment. Where are you watching from? And had you ever really thought about the junkyard forming in orbit before today? Tell me. I read every single one, and I'll see you in the next one. Stay curious out there and keep looking up. There's more happening above us than most people ever realize.